Hey guys, I'm Parmida Zenouz. I'm a master's student at Okan University in the field of architecture, and today I'm going to be explaining my project, which is about ecological skyscrapers. But before I'm explaining my project, I want to share some of my experiences at Okan University with you guys. And let's just watch that video, and we'll be right back. Now we're back. Let's get started. Well, I've designed an iconic building. You know, when someone mentions New York, London, Paris, or Sydney, like many people, you'll immediately associate the city with its famous structures. The Empire State Building, Tower Bridge, the Eiffel Tower, or the Sydney Opera House. Iconic buildings are a definition of a city, a statement about its history, ambition, or how it wants to be seen. Often they have a story. So iconic buildings can affect the way that we feel about a city, often giving residents a monument to be proud of. But what is it that makes a building iconic? Does it need hundreds of years of history, such as St. Paul's cathedrals in London, to stir emotion? A building can be iconic for many reasons. If we look at a few of the truly iconic buildings in the world today, we realize that these actually have very few similarities. For instance, the Sydney Opera House, the Eiffel Tower, the Empire State Building, or the Burj Al Arab. They're all so different in height, different in shape, different in function, but what makes them iconic is probably their unique design, their symbolic value, and their history. The impact they've had on the city where they were built. Why do I want to design a sustainable skyscraper? You know, skyscrapers can beautify and modernize a cityscape, can improve the identity of the city, can improve the value of the land around it, can, become tourism destination, can bring numerous job opportunities, and can show a sign of greatness. And the more important thing is, skyscrapers could create more living space for the increasing population. So let's get to my design. Well, I've designed a sustainable skyscraper in East Azerbaijan. Azerbaijan is part of Iran. Why? Well, the unofficial new urban suburbs and the rising cost of land and housing within cities have made it difficult and even impossible to provide housing for the low-income or middle-income classes. However, the tendency to build towers or high-rise buildings at this time is something that cannot be easily done. So I've tried to design this tower based on modern architecture. And I've also tried to create greenery on the roofs and to create a climate of public and open spaces and how the units are positioned while providing the most privacy for the tower dwellers. So, and now I want to show you the exact location, geographical location of East Azerbaijan in Iran. Let's see that photo and we'll be right back. Well, in this section, I want to explain the details. The weather. First of all, we're going to start with the weather. According to the General Climatic Divisions, East Azerbaijan is located in the cold climate region, or, Western Mountains. The winters are relatively long, with the cold beginning in early December and continuing more or less into April. In general, the short spring separates winter and summer in this region. I want to share some of my findings and analysis in here. Let's watch the video and we'll be right back in a few seconds. And now we're going to be talking about temperature. Well, during the study of East Azerbaijan biochemical structural tables, the maximum absolute temperature recorded in this region is 40 degrees in July, and the minimum temperature is minus 19.6 degrees in January. And now precipitation. Well, rainfall in East Azerbaijan, which usually starts in October at a high level, increases from March to its peak in April and May. Well, in total, March to May is the productive period of the East Azerbaijan plain. And now let's talk about relative humidity. Well, the proximity of East Azerbaijan to Lake Urmia, due to its climatic characteristics, doesn't have much effect on the moisture content of this region. And for the wind, the east-west and northeast-southwest directions were the most important wind directions in this region. And now, in here, I'm going to be talking about sunlight. Well, in this city, the angle of sunlight, or you can also say sun height, fluctuates greatly throughout the year. The minimum radiation angle is observed in January, which is 28 degrees and 33 minutes. And as the summer progresses, the angle of radiation gradually increases as the spring equilibrium increases to 52 degrees. And this increase continues until July. This angle reaches its maximum value about 120 degrees in winter due to the sun's inclination toward the vertical line, and in summer it reaches its minimum value about 60 degrees. And in this section, I'm going to be explaining my site analysis and the details of the site. I've actually made the video for you guys and I want to share it with you. We're going to watch that video and we'll be right back in a few seconds. Explain wind analysis. Well, the east wind is the strongest and most persistent wind that blows throughout the year and accounts for 31% of the region's winds. The western wind is the second largest wind behind the east wind and accounts for 24.1% of the annual winds. Winds from the south are favorable winds, and the duration of the wind is 2 months per year. So, to prevent undesirable winds from entering the site, a row of trees can be planted in front of these winds. The second way to deal with undesirable winds is to rotate the building properly so that it has the least frontage facing these winds and can reduce its severity by planting trees along the path. Let's see some of my sketches and we'll be right back. So, let's see my final site analysis, and we'll be right back. Well, in this section, I'm going to be explaining the specification of my design. Well, this residential tower is about 300 units, including suite, 1-bedroom, 2-bedroom, 3-bedroom, 4-bedroom, 2 stories underground, and commercial space, welfare, and community space on a 20,000 square meter site located in East Azerbaijan. The ground floor is about 4,500 square meters, which decreases with the height of the floors. In this design, I've tried to create a shattering climate in different floors that create the same roof because of the convenience of the residents and the modeling of the principles of sustainable architecture, which is the creation of the green roof. Green roofs are repeated on all 5 floors. And now let's talk about the concept of my design. Well, the design I've come up with is made up of 3 cylinders, the height of which is greater than the other 2, using a central void in the middle of these cylinders to connect them, creating a space for air circulation and the creation of green roofs. All 5 floors have one. And now let's check out the plans, sections, and we'll be right back in a few seconds. Thank you guys for watching this video. Be sure to rate, comment, and subscribe.